We've got the global marine opportunity. I think it's been spoken about quite a lot, but in 1980 the global installed capacity of wind power was 10 megawatts. And today that same installed capacity is now 100 gigawatts. In the installed marine capacity in Scotland, it's around 10 megawatts. And if you look at the International Energy Agency's Blue Map medium growth scenario, it means that in roughly 35 years' time, there could be 46 gigawatts of wave and 13 gigawatts of tidal, so 60 gigawatts in total. So if you offer a trajectory looking at comparing marine and wave and tidal, comparing wind and wave and tidal, you can start to see that the capacity is quite tremendous. I'm not going to go over the tidal and wave resources of Scotland. I think we've sort of covered them off in other parts of this conference. But if you look at Scotland in particular, the Carbon Trust estimate around 11 gigawatts of wave and 4 gigawatts of tidal capacity potential exists in Scotland. So a significant capability. So why are we involved, particularly in the marine power sector? And I'm going to call on some words that Professor Sir Jim MacDonald said yesterday, if anybody had the opportunity to see his lunchtime session. He talked about the requirement in order to drive new activities being a triple helix of the private sector, academia, and the public sector. And I think this is what we've managed to achieve in Scotland and are still working on. But to echo his words again yesterday, this is an ongoing striving for collaboration and the need to make sure that those three parts work together. And I apologise, I know some of the slides are going to be a bit busy in this presentation, but understand All Energy will be providing them on the website, and this again is something that we are continuously working on, so we would welcome any input as well, or feedback after this presentation. So we have got, and we are very fortunate to have innovative universities and companies in Scotland, and I know the ETP is here as well today, so you can go and see them in the stand if you want to speak more specifically about them. And there are many test and demonstration capabilities available. I could spend quite a lot of time, but I'm sure the chair would usher us on if I was to run through all of them. So I won't cover them in this particular speech, but again, there is plenty of information available in the Scotland stand in terms of what support is available through to support innovation through either universities or through test and demo facilities. We have got public sector support. We've had Waters 1 and 2, we have the Socttish Prize, and we've also got obviously ROCs. And again, we can give more information on that. And we've just spoken about the excellent wave and tidal resources. And not forgetting as well the very influential role of EMEC in driving forward the whole wave and tidal scene. So we do have, as a result, many global leading marine power companies here. I believe that Scotland now has more devices being tested or developed in this country than any other country in the world, which is quite an achievement. I always tell my colleagues that what other industry could you say Scotland was actually leading on? Well, I think it's whisky, but apart from whisky, I like to say that marine energy is an industry that we are leading on in its early development stages. So this is an example of some wave and tidal companies currently operating here, whether it be tank testing, scale testing, or full-scale testing, and you can see the initial deployment and the proof of value. And since this is about the current state of play, this presentation is really about that, about what is actually happening just now. And one of the things that we're starting to pick up, again, apologies, busy slide, but you'll be able to pick up on it later, but we are starting to see evidence of consolidation. We know that old VHS versus Betamac dilemma that's going on, and that will happen. I mean, it undoubtedly will happen in this industry like any other, but the jury is out as to how that will happen. But you are starting to see some evidence, particularly in tidal. You're starting to see the sort of emergence of the horizontal axis, and as just based on analysis of what's going on just now. In wave, not so much. We've still got a variety, and bear in mind as well, a lot of the devices could potentially be deployed in very different markets. They may not all necessarily go into large-scale domestic electricity supply, so there's no guarantee that at the end of this process we will end up with one wave device and one tidal device. Sort of original thoughts just now is we could actually end up with a few sort of accepted devices going forward, but it is too early yet to say. But it is interesting when you start to see what is actually and what's happening, the converging. And I'm sure there's there's a lot of work that could be done in terms of how these devices are actually found, and I know there's lots of technologists that could give you quite good papers on it's not necessarily always the best technology that wins, but there's lots of various factors that come into that. But it's interesting analysis. But this is a challenge that we face, and these costs are obviously based on the first array projects. We do have to drive costs down, regardless of whether other forms of energy will actually increase. We know that the cost of energy is something that has to be brought down to make the industry more achievable over the long term. And as you can see, these are worked out in terms of capital operating and annual energy costs. It's difficult to sort of have a clear definition just now, because bear in mind, the devices that are currently in play, the ones that we can actually be sure of that are actually generating electricity, are largely prototypes, which is the most expensive way to actually determine long-term running costs. But costs will be brought down in a larger way by learning by doing, by innovation and economies of scale. So this is an indication, and I only say it's an indication, and this is purely based, although I like to think it's based on the best possible evidence, which is straight from the horse's mouth, because I've obviously worked with the companies that we have. But this is looking at the tidal costs, as you can see on the left-hand side, and working down. And these are just projections. Again, difficult to predict, because obviously we're talking and dealing with companies that are usually at the very early stages of device development and testing, and a lot of them don't have, well, none of them really have final devices probably in evidence yet that they would do for very large scale sort of procurement. But this gives you an idea of how the costs can go down. And again, so I wanted to focus to give you a real live example of innovation and work, and actually sort of speak from the coalface, so to speak. So to the people who are actually out there, the pioneers who are actually driving forward and developing these devices for us to benefit from in the long-term future. And ScotRenewables is a very interesting company. They have got a horizontal axis design, but they've got 2 generators on it. They use moorings and anchors for the fixation, because installation cost, as any device developer can tell you, is extremely difficult. It naturally yaws, and it can be installed in a range of depths. So it can be, you can sort of move it about in terms of access. It works out, it's easier to maintain, and it has a storm survival mode. And because as well it's floating, obviously it avoids the risk of impacts. And here's wave. Again, same thing, the curve going down from the left to the right, and the same ways that hopefully it will be brought down. And another innovation at work. If you caught Newsnight Scotland, I saw that Oyster was being forecast there after Fergus Ewan's comments yesterday, and the wonderful announcement Aquamarine did yesterday in terms of their consenting. And Oyster is a very good example of how this project or this device has been developed, and how these device developers have really learned through doing, because they're actually working at sea. And don't be mistaken in terms of Wave and Tidal, there are very few real large-scale devices operating at sea in the world. So these are global pioneers. So Oyster, their first prototype had 4 piles, which, as you can imagine, was both expensive and complicated in terms of installation. The current one that they're operating just now is a 2-pile system. It works in a hydraulic arm. But as you can see, the next generation they're working on is actually a monopile flap system. So this is all about working at sea, working in the sort of extreme environments, and then actually learning and sort of working out what the best way can be done. So where are we now? We've spoken about rocks, we've spoken about contracts for difference, and you can see that going forward. We have got the Saltire Prize, we've got the NER 300, Reef, and etc. But as you can see, we're starting to show a gap, the 2017 time span of support, and the type of support will continue. This is a long-term industry, and it won't happen in a quick burst. So moving forward, as the Minister said yesterday, we continue to be ambitious. To quote, I was almost tempted there to quote Star Trek, but I really will try not to show my geeky side. We have got a continuing ambition. We will continue to lead the way as a location for device development, and we want to continue to lead the world in demonstration in wave and tidal array deployment. And that would also want to lead on to a desire to lead the world in exporting wave and tidal solutions, building the industry. But we recognise that there are critical issues going forward, and these are the issues that triple helix faces. We don't believe this is an issue of the government or an issue of academia or an issue for the private sector. These are critical issues that all three parties have to work together to achieve. The announcement of MRCF is a step towards that, and we will continue to look at more and innovative ways to support funding and investment for the industry. The industry itself has to continue with device development and technology proving. There is an ongoing development cycle there that they have to do. And there's a need to build and support the company base. We need the successful deployment of these arrays, the ones that have been spoken about. We need the successful deployment of the tidal arrays and obviously wave arrays, which will come. And we need to work on the grid infrastructure problems. This cannot end up being a blocker to this industry going forward. We have to resolve VMR. And also for us, one of the things that we're looking at is the ensuring availability and the skills provision. We're very fortunate in Scotland. We've got a very strong engineering base. We're well known for it. We've got very active universities. We have got companies already taking great advantage of our graduates and an engineering skills focus. But one of the things that we're also working with is how do we work with the schools, the Skills Development Scotland infrastructure, and how do we make sure that when these companies get to maturity and need greater sources of engineering skills, that skills pool will also be there for them. So this is a long-term ambition, this is a long-term commitment, and this is something that we want to work together with industry and academic sector to achieve. Thank you.